Excuse me. Okay, now why, OBS, did you do that to me? I think it was because of the Windows update. There's nothing else that changed. Okay. Thank you, Jed. My OBS just randomly unset my microphone source. But yeah, dude, I don't know why, but you did wreck the chat again by redeeming first. I don't know why my chat is doing that. But congrats. You're acting like Microsoft needs a reason to screw up your computer when you ever learn true. Bill Gates is a crafty son of a bitch. An appeal for some assistance may catch you off guard. Ooh, that's a cool fortune. Never? Oh, you're always ready for everything? Okay, I'll reread this problem from scratch. Repairing a chain. Do you know why the young craftsman in the picture is so deep in thought? He has 5 short pieces of chain that must be joined into a long chain. Should he open ring 3, first operation, link it to ring 4, second operation, then unfasten ring 6 and link it to ring 7, and so on? He could complete his task in 8 operations. He wants to do it in 6. How does he do it? Everyone's always asking you for assistance. That's fair. As both a software developer and a dad, I'm sure you get requests for assistance all the time. All right, let's bring these let's bring this text into Journal++. Is it silly? I don't immediately know how to do it. You don't say you need more than 5. Okay. Hey, Roxra. Here's my pen. Okay. So... okay. So if you do it the straightforward way into a long chain, I wonder whether this might be playing with the definition of long chain. Yeah, the 8 operations would be unlink that, hook it around 4 is 2 operations. Do it again here, 4. Do it again here. Wait, isn't that 6? No, and then also there is 8. How do we save an operation? Break links 1, 2, and 3. Use link 1 to join 6, 7. Okay, so we're breaking all 3. You're saying to use 1. Oh. And so that's 1 break and 1 join. So that's only 2 operations. And then the same thing with 2 for 9 and 10. Yeah, you got it, Jed. Yeah, that's kind of like the obvious thing, but this is a lot more clever. Thank you for the streak. All right, nicely done, Jed. Correct the error. With 12 matches form the equation shown. The equation shows that 6 minus 4 is 9. Correct it by shifting just one match. Easy peasy, lemon squeezy. You let me think? 6 minus 4 does not... Yeah! Oh my god, Roxra! That's probably it. In my opinion, that's valid. Just taking this match and putting it here. I mean, it's a true statement, I think. I'll turn it into a plus? Oh, yeah, that's probably the intended solution. Roxa, yours is really clever, though. I like where your head's at. I guess into a less than or equal to. Well, you need 2 matches, though, right? Oh, wait, no. I'm sorry. I see what you mean. Yeah, it'd be like a weird one, but yeah. Wait, less than or equal to. Yeah, okay, you put it there. I see. Yeah. You can post it, Cold Gold. I probably can't do it. Maybe someone in chat can. You got it, Roxer? Hell yeah. What a G. I want to look at the answer to this, because I want to see if they, like, thought of Roxra's idea. Two solutions are shown. Oh, no, so they were only doing plus signs. No, those are the only two solutions that they provide. A Lebesgue measurable but non-Borel set. We give an example of a subset of the real numbers which is Lebesgue measurable but not Borel measurable. But S consists of the set of all irrational real numbers with continued fraction of that form, such that there exists an infinite sequence where each a sub I sub k divides a sub I sub k plus 1. This is like Inception. We're doing two levels deep of subscripts, and we have to go deeper. Being shown that the set is Lebesgue measurable but not Borel measurable, and Coldwell wants to prove that. What words? Stop using AI. The wave. Oh, cool. I'm glad to hear it. This is the... Oh, for the seaweed. Noish. Look at it go. It's wiggling. Yeah, it looks good. You understand what are analytic sets, etc. Can be shown that S is an analytic set, meaning it is the image of a continuous fraction. For some Polish space? Is that a Polish person's house? Consequently, That's a universally measurable set. Okay, this link leads to JavaScript :void 0. Wait, oh, this link leads? Okay. What? A definable set. Is there an undefinable set? Just wondering if this is super hard. Is it 6 years above my pay grade? I think me too, Roxra. Let's see if we can jog something loose if we do enough Googling. In the mathematical field of descriptive set theory, a subset of a Polish space X is an analytic set if it is a continuous image of a Polish space. Okay, well, what the hell is a Polish space? A Polish space is a separable, completely metrizable topological space. In your case, that didn't make sense to you. That is, a space homeomorphic to a complete metric space that has a countable dense subset. Oh, okay. I guess the name Polish space is because of a lot of Polish people initially studied them. You went to a Polish place once that had decent pierogi? I make pierogi every now and again. I made them on stream once. It's a family tradition for me. Saying someone thought to look at that set of real numbers. If I retire from being a doctor when you're like 65, 70, then you go back to school for math. I mean, that's not a bad way to live life. Like, make your money and then do what you really want. Or maybe being a doctor is what you really want, but eventually you want to do something else. Yeah, and there's no reason you can't do both. This is interesting. Like, what's an example of an irrational number like this? I guess you would probably start with the definition. Or you would start from the continued fraction and see what irrational number you get out of it. So for a continued fraction to be an irrational number, what's the condition? Do they just not, do like the b's in this image not have a pattern? Oh, this is kind of interesting. I don't think I've seen this before. That pi is irrational using the full continued fraction for tan of x. Huh. Depends if you like thankless work or not. The 20-year-old would be dumbfounded with me next to him or her. I mean, you would do it just because it's a structured way of learning math, but you could just self-study it too. Okay, this is the condition for irrationality. If they're positive integers with a sub k less than or equal to b sub k for all sufficiently large k, then, oh, that's cool notation. PhD out of spite. That converges to an irrational limit. So I feel I guess I mean That's a looser condition than I would have thought for irrationality. Taco does math? Great name. Am I at a maths university, I assume? I just got a master's in applied math. So, as of recently, I am not. Someone is in civil service, which requires cracking an insanely hard exam. Decided to quit, study math for like 3 months, and got into grad school. Wow. Well, being able to get through the civil service exam maybe helped him get in, too. But yeah, I mean, probably just a smart person in general, so I believe it. Um, when I'm 70, you need to be streaming so I can ask you questions from my lectures. Okay, I'm guessing I'm at least 10 years older than you, so I'll be in my 80s, but I'll be streaming math in my 80s. Don't worry. Okay, so why are continued fractions involved? Oh yeah, because the thing comes from continued fraction. So I don't know, like maybe I could at least think about this a little bit. Like, what's the definition of Lebesgue measurable? I've never done measure theory anything cold gold, so I wouldn't depend on me to actually come out with anything here, but I'll give it the old college try. Also, okay, so maybe we should start with Borel sets. All sets that can be obtained by countably many operations of unions. Set complement. Complement? That must be a typo. And intersections. From the collection of open intervals. Huh. Cursological. Hello. In my experience, learning anything interesting through Wikipedia is 90% of the time leading down a steep and deep rabbit hole. Yeah, I probably shouldn't be using Wikipedia for this, but I don't know. I just feel like it right now, I guess. An arbitrary subset of the real numbers might fail to be Lebesgue measurable. Every Borel set of reals is universally measurable. Okay, so that's exactly what Cold Gold wants to prove. You know, I bet we could find a Stack Exchange thread on this, because if it's on Wikipedia, I bet someone's had this question before. This is a cool looking website. It's not the exact same problem that we're... interested in. But speaking of doctors, there's this one lady who visited my institute recently. She got an MBBS, went to study more medicine, proceeded to get a PhD in math instead. What? She got an MBBS, went to study more medicine, proceeded to get a PhD. That's wild. What even is an MBBS? I haven't. Bachelor of Medicine, Bachelor of Surgery. It's equivalent to an MD in the US. Okay. Dr. X. And she could also change her first name to Doctor to get a third Doctor in there. The boring pianist, the moral of the story, math is the actual medicine. Yeah. Some say that laughter is the best medicine, but it's actually math that's the best medicine. Okay, so this person is talking about the exact example that Cold Gold brings up. I wonder if the comments talk more about one of these. Describing mandatory topology to sick patients. There you go, Roxura. Example with one of insomnia and boredom. No, I don't. This thread, they talk about it, but they're not really. It's not really the proof that we're looking for. Two to the left 0 subset of R. There are 2 to the left 0 Borel subsets. Oh, yeah, sorry, Cold Gold. I don't know if this is gonna be the exact thing that you're asking about. I don't think I can answer your question. So I'm hoping that Stack Exchange answers it for me. Yeah, sorry. I might just leave it there if you don't want spoilers, because I think all I can contribute is Googling it. At some point, I would like to come around to learning this stuff. It's probably not going to happen for me anytime soon, though. So unless someone else wants to ask a question, I think we'll go back to doing puzzles. Oh, wait. We need to go back to our amusing problems. Okay, 4 out of 3. A joke. 3 matches are on a table. Without adding another, make 4 out of 3. You are not allowed to break the matches. That was my first thought. Wait, so this is a joke. Is there just some wordplay that's happening here? Make 4. Oh, make. Oh my. I know it. 4 out of 3 matches. I made 4 out of 3 matches. That's why it's a joke. Three and 2 is 8. Another joke. Place 3 matches on a table. Ask a friend to add 2 more matches to make 8. I already know the answer. I put the 3 matches like that. My friend puts the 2 matches like that. And it's a crappy 8. IV could also be possible. True. Yeah. I mean, the joke is like they're making you think that you're supposed to get 4 matches, but we're just spelling out the number 4, I guess. 3 squares. Take 8 small sticks or matches, 4 of which are half the length of the other 4. Make 3 equal squares out of the 8 sticks or matches. Why are they giving us this choice all of a sudden of sticks or matches? Make 3 equal squares out of the 8 sticks. I got it, I think. Do I have it? 1 big match, 2 big match, 3 big match, 4 big match. But now I have too many. Yeah. I guess Clodal and I got to the same place at the same time. How do we get only 3? I mean, if we make 4, we also have 3. If we want to be smartasses about it. Is there a better way we can do this? What about... Hmm. I guess I'll keep this on the screen just so we have it to look at. I guess we could have also done the big sticks all on the outside. And the small ones on the inside. Can we be sneaky and make a... No, we can't make a triangle. The ratios wouldn't be right. Why did that get auto-modded? What? Tanoshi, hey, I'm doing good. How about you? just watch your language though. That's a little harsh. um I'm just joking. You're doing good? That's good to hear. Make 3 equal squares out of the 8 sticks or matches. You have one long stick too many? I'm wondering if you have to, like, double up. Like, put 2 sticks end to end in some way? Could that work? No, that makes 4 still. Dude, how do you make only 3? Or is it a trick question and... 4 is an acceptable answer, because there's also 3. Yeah. But if anything, like, you know, I've made 4 distinct sets of 3 squares. You did it? It's probably hard to type it, but if you can. Too many longs? Okay. Uh, Maybe Tenoshi. I don't see why not. Oh, Cold Gold also has that? Then you can do it. Do you, like... Is it like this, but you shift it over? I guess that's 3 equal squares. Huh. Wait! No, I think okay, wait. X with long sticks. X with long sticks. Short stick, short stick, short stick, short stick. Bam! You got that too? Nice. You got another way. Are you able to describe it? One square made out of the green ones. 2 parallel longs. Oh! Yeah. I guess you're making like a pound sign. Fair enough, Tenoshi. Hey Leo. Uh I was doing puzzles from this book maybe like a week or two ago. I decided to come back to it. It's Moscow Puzzles. Just until I wait for someone from chat to have a question. Yeah, so we could do 5 with a pound sign. Do your problems? Ah, why not? I just want to look at the answer to this one. 17? Oh yeah, so the only solution they provide is the x's. You have a similar one? I want to see what's up with Leo. We can think about yours too. How many closed polygon can you make out of a screen lock pattern? Oh, like the Android screen lock pattern where you have the 9 dots? How many closed polygons? Wolfram Alpha? Yeah, it is really helpful. I wish it wasn't so paywalled, but it is a great website. Well, you can certainly make 4 small squares. I want to do Cold Gold's first, and then we'll go to yours, Leo. You can do 1 big square. You can do 4 big right triangles. No, it just says closed polygons, so I don't think regular. You can suggest questions. If you make an account, it can even auto-accept your quiz questions to go up. Oh, interesting. I don't really have questions like ready to go, but I can maybe do that. It's complex to explain, but I will try. For the previous one, boring pain is saying 1 long vertical, another long vertical, shift half a stick down, half a stick horizontal. So like that. And do that another time? Fourth one horizontal. Oh! Oh, actually, I think that ends up being really similar to what I did up there, just a different construction. Yeah, but that's a nice way to think about a boring pianist. Oh my god, please. Okay, there we go. You cannot end a line on the same vertex twice. Wait, you don't have to come back to where you started? Or you... Is this not bad? How do you ever make a closed polygon? Am I misunderstanding you, Cold Gold? I don't have an Android, so I don't actually know how the passcodes work. But like, are you saying I can't come back to this vertex? 6, 7, and peace out? I have not, Slim. You can. Wait, no, but you can still make closed polygons. You can go through. Oh. So you're saying I can make. Wait, how do I. If I do that? Like, I made a square if I do this. That's what you're saying. Do you have to use... I doubt you have to use all the vertices, right? You can go through lines, but you cannot come back to the same vertex. Yeah, I think this is a valid way to make a square then. It's just a puzzle that Cold Gold suggested based off the last one. I should probably put it on screen. And so I don't have an Android phone. Oh, I don't know how to spell Android either. But apparently you cannot hit the same vertex twice with an Android lock screen. So oops, no, redo. So like this is not a valid lock screen pattern, but this is, and this makes a square. Do you think it made my voice more cheerful? It'll be easier. I think your voice is already easy to understand. I don't have a problem understanding you, Slim. Numbering them like a phone. 1, 5, 4, 2. Yeah, that'll make a triangle. Oh, I'm sorry. Roxray, you asked what formative is? I read that and I forgot to address it. uh I don't know what you mean, what is formative? That's not like a math word. Formative as like an English word just means like something that happens as you're forming, I guess. Like your formative years are your childhood years. Well, not necessarily childhood, but like it could be. You can just do an integral for displacement in physics. Yeah. If you integrate velocity with respect to time, you end up with displacement, I believe. Class algebra based, but it's staring you in the face. That's exactly how I got into math. My algebra-based physics class, I made a connection in that class using what I was learning in calculus, and I was like, oh, that's kind of like the coolest thing ever. And that's when I started to actually enjoy math. Is your voice cheerful enough? Maybe you need more pep. Slim, you are perfect the way you are. To count if you flip, rotate. I think we should count like rotations and mirrors. Rotations and reflections, I guess. Formative apparently means a place where assessments. Oh, I don't know. What about 2, 2, 7, 1, 8, 6, 4. I guess I would count this as 3 polygons. 4 polygons. You can do 6. Oh, wait, so you're not asking total, but just like the most polygons in one pattern. Okay, that makes the question a lot simpler. Okay, Leo, you had 2 questions, and Cold Gold just had 1. That's why I started with Cold Gold. I won't spend that much longer on this one, just so I can get to yours also. Okay, so if we're doing it only in one go, what's the most close polygons we can make? Let's see how good we can do. What is this bias? Probably not that much. It's like 4 or 5. 6? I don't know. They're 2 parts of the same whole. The only hole you know is the one you left in my heart. Well, there's 4 small polygons. There's that, that, and that. But there's also this. Like, you can take different combinations of those small polygons also. So wait, so that's 4, 5, 6, but also 7. The entire thing is 8. Yeah, I think I agree with you, Jed. I think that's 8. I just kind of randomly made those lines too. I wasn't even thinking about it. 10? Maybe. I don't see 10, but it's possible. Oh, I don't know. Show my polygons again? Okay, so there's 4 small polygons. This combination of 2 makes 5. This combination makes 6. 7. 8. I guess 9? I'm not really doing a good job keeping track of these. Okay, yeah, I maybe like Jed's notation. I don't know what you have in mind for A, B, and C, but I'm just gonna guess A, B, C, D as our small polygons. A plus B. Yes? Okay, good. A plus B plus C. A plus B plus C plus D. Hey, Floppy. Yep. Arson. We love it around here. B plus C. B plus C plus D. Yes, this is good notation, Jed. I like this. Hey, Myro. C plus D, and finally D. Yes, that's 10. I like that. Aeneas is suggesting a new line. Or a new, like, passcode. 7, 2, 9, 4, 3, 8, 1, 6. Look at you go, Aeneas. This has to be a lot more. A, B, like, A, B, C, D, E, F, G, H, I? Yeah, this is... I forgot the last... Oh, from 5 to 6? Or 6 to 5. But oh my, I'm not drawing this perfectly. It's kind of important for this one. Do I have graph paper, don't I? Let me. Oh wait, graph paper. Okay, Ain is saying, uh, no, 7, 2, 9, 4, 3, 8, 1. Ooh. No? Oh, Bimps is just heckling me. 1, 6, 5. Okay. It's wrong. Very wrong. Supposed to be. Thank you, Famished. 4 letters, 10 polygons. 4 plus 3. Yeah, it depends on how they're connected to Noshi. I did kind of notice there's an interesting thing happening there. Damn it, Jed. When you're right, you're right. And you're always right. Third time's the charm. Let me get the question back on screen too. Zoom way in. You know, I should just okay. You're double right. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One, two, 3, 4, 5. One, two, 3, 4, 5. Stop snapping. Stop snapping. I sure could have, Tanoshi. I just don't do things the smart way. I do things the dumb way. Well, it's better to make it bigger than to zoom. I think. Uh... Okay. 7 to 2. 2 to 9. 9 to 4. 4 to 3. 3 to 8. 8 to 1. 1 to 6. 5 to 6. Okay. Work harder, not smarter. That's my motto. That's not how you make an A. A, B, C, D, E, F, G, H, I, J, K, L. I'm handwriting it. That's the joke famous. I work harder, not smarter. You got 56, Ludwig. Really? In one passcode, you got 56? We do cases each, like count number of cases when 3 dots are connected. No, I think we're just going for the absolute maximum boring pianist. I don't want to enumerate all these cases, but there's a bunch of them. We have at a minimum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Use the Greek alphabet? Yeah, I'm willing to bet that Aeneas has cracked 50 also. Theoretically 91 polygons? Yeah, I mean, we could do an upper bound if we sum chooses. We said there's 13, right? Like, oops. This is the theoretical, like, upper bound. Hey, it's a good song. Infinity? Just by drawing lines between 9 dots, you have 56 total shapes. Okay, Ludwig. Hey, Dessen. Okay, before Leo dies, I think I do want to talk about Leo's questions. Not the answer, you have to remove any combination containing A. Well, yeah, Jed. We're just saying this is like an upper bound. It's definitely not the actual answer. I actually, okay, before I look at Leo's, I do want to. What is that number though? 8191. It does sound smart. And you see Matrix might help. I'm not sure. Oh, you know, it's kind of interesting how it kind of forms a sigmoid function. That makes sense with how choose works. I'm curious if there's something deeper that you can say there. I think it has, Dessen. Um, well, like it might not be a very good upper bound, but it's an upper bound. Um, Definitely for algorithms, Dessen, counting is important. And like algorithm analysis, that's where my mind goes. What is choose? They're also called like binomial coefficients. If you've seen like, you can have 5 choose 3. It's related to like permutations also. Oh, maybe we talked about that integral. It sounds kind of familiar. But there's a definition for choose involving factorials. It's a number of ways, exactly as Tenoshi says. Just stole main questions and made a quiz? Maybe. Okay. How does that relate to the sum? Oh, it's because when we're talking about, we have 13 like small polygons, so to speak, that I gave a letter to. But we can make other polygons by combining like A and G. That makes one bigger polygon, or A, G, and D. And so, this is not the answer to the question. It way overcounts, but we can get an idea of how many shapes there are, maybe. Just by naively taking every single like pair of these small polygons. It overcounts because it counts like A and J, which is definitely not a valid polygon. But like A and G is valid, A and D is valid, H and D is valid. So it starts off like all the ways to choose 2 out of 13. Well, also all the ways to choose 1, but you can also do it with 3 polygons and so on. Okay, looks like I got some linear algebra from Leo. From Leo lectures to Leo quizzes. Let LV to V be a linear map over a finite dimensional complex vector space V. Let P of X and C of X be its characteristic polynomial. Oh god. Linear map over finite dimensional space. Is characteristic polynomial the one you get from doing eigenvalues? Look at this, it looks fucking awesome. Or is characteristic polynomial something else? Okay, it's the eigenvalue one. 13, 12. I'm not sure, Tenoshi. Not sure where T came from. Which following are determined by the characteristic polynomial. Okay, so theoretically, if we knew that L is a linear map and we only knew its characteristic polynomial, what do we know about V? Well, we know the dimension of V. That's the degree of the characteristic polynomial. Wait. Yeah. Right? Well, does it need to be square? This is a quiz that Leo Lectures over on YouTube made. He's quizzing me, I guess. But yeah, Leo does stream over on YouTube, and I guess just for fun, he gave me this quiz that he created. It's only these 2 questions. Indeed, I do. Oh wait, so okay, surely we're only talking about square matrices, because you don't really do eigenvalues for non-square matrices, do you? Oh, and yeah, I think we know it's square because it's V to V. Also det, yeah. Probably faster counting, probably. Oh, that's okay. We're not gonna solve it. I assume that you're just like trying to show it off. That's a pretty disgusting one. No? Okay, I won't show it then. No worries, Tenoshi. Hey, I'm really happy to hear that it feels like home. Thank you so much for hanging out, and have a good day. Oh, yeah, we can try it after this. I will show it on stream, then just give a little teaser. What is the plus? Does that just mean we're taking the greatest integer instead of the least integer? That's his cursor. Oh my god, okay. Okay, well, we'll try to think about that later. Mbox. It's a good emote. Polygon question if you had instead starting from 3-1, started from 2-2. Oh, interesting, boring pianist. German uni integral B? Oh god. And and Femvox, I think I'm ready to plan out the reading group. If I haven't waited so long that you're no longer interested, at least. I don't know what conjugacy class is. Yeah, Femvox, I'll send you a DM soon about it. So we know the dimension of V. That's the degree of the characteristic polynomial. Do we know the rank? That's a good question. The number of distinct. Well, ooh. I don't think we know. Do we know? No, wait. If you have a 0 eigenvalue, your null space has dimension more than 0, and the rank nullity theorem would tell you about the rank of L, because we do know the dimension. But do we know everything about? Do we know exactly the dimension of the null space though? That's what I'm not sure of. It's like the set of maps TLT inverse. Oh, okay. Literally added the question now. Null space and image in there too. I know the dimension, but not the rank. I mean, you cap at that, so I'm maybe missing something obvious, but that's what I'm thinking. Well, I mean, it's kind of like if there are no 0 eigenvalues, we do know the rank of L, but if there are 0 eigenvalues, I'm not sure if we do. Christmas. That's also pencil to ask you linear algebra questions. Hope you're doing well, Fizzbuzz. God, okay, this is gonna bother me. Like, if a matrix has 2 0 eigenvalues versus only 1 0 eigenvalue, how does that show up in the rank of that matrix somewhere? Uwu? Math with Ming quiz question, which most people got wrong. Okay. I don't know. Let's look at the other options. I'm kind of torn on the rank of L. Number of distinct eigenvalues of L. Well, that seems like a gimme. The dimension of each eigenspace of L. No. We need to know what L looks like to know the dimension of the eigenspace. The character polynomial helps, but not entirely. The nilpotent degree of each eigenvalue. What the hell? Hey, TT. TT360. Minimal n such that L minus lambda to the n is 0 on the generalized eigenspace of L at lambda. Surely. No, I feel like you would need to know the rank of L for this too? Or maybe not. No, I think you might know this. This is just a gut feeling that I think you know this. I don't know. Well, if you'd assume I might know anything. The similarity slash conjugacy class of L. I don't know how you test for that. The only way it could help you is maybe with decompositions. But I don't think you know about decompositions only from the characteristic polynomial. You clipped me saying uwu? You don't need to apologize for the uwu clips. Love it. I should compute. What is the companion matrix? Am I allowed to Google things in this quiz? Is it open internet? Too late? You don't know, but it does sound friendly. It reminds you of the companion cube in Portal. Do you know the additive decomposition? Portal is goated. I don't know the additive decomposition of a matrix, no. Oh, the co-op campaign is good. I did it with a real life friend a long time ago. Doesn't sound like he knows more than I know about these. I haven't heard about any of these. Yeah, I'm getting the same feeling. This looks like it might be helpful. I don't know exactly how yet. Some people define imaginary numbers with matrices. Oh. So if, well, okay, I guess if two matrices have the same characteristic polynomial, or like, okay, it's possible for two different matrices to have the same characteristic polynomial. So this, at first I thought that this would just tell us everything we needed, but I guess not. The tail part is the nilpotency part of a matrix. Some furry thing? Maybe. What? What is this graphic? This is crazy. This should be a poster. I like this. Get it off your screen? I don't blame you. Why are pseudo inverses down here? Shouldn't they be in square matrix land? Just bash with the Jordan decomposition? Oh, that is like a Jordan form. Oh, it's, I guess almost. I don't know. Um, Jordan form leads the Bulls to 6 championships. Can't hurt. Jordan additive? Okay, so this is what Cold Gold said to... Oh. Bruh. Is it Jordan Chevalier? Oh, this might be it. Right, Fizzbuzz? Jordan form? I think the second... I think this is what Destin is probably talking about. The other... Yeah, because one part is nilpotent. I'm curious to see what this additive thing is first. My face is... Wow. Dude, Leo, that's too far. Unmodded. Come on. He just called people's face nilpotent. Just kidding. Jordan form, rational canonical form, where you see Kirchhoff's polynomial as a modular sum. I'm just gonna control F characteristic. Ugh. Galois theory, get that off my screen. Probably want the other one? Okay, I was just curious to figure out what Destin was saying. It's pronounced... Thank you, Leo. Galois. Mayonnaise. Hey. Uh, similar matrix of the same characteristic polynomial. Really? I didn't know that. I feel like that's probably simple enough to show. I don't know how you would immediately though. I saw that Destin on the other page. P sub... So the characteristic polynomial of any matrix A is equal to the characteristic polynomial of the Jordan normal form of that matrix? Oh, well, yeah, sure. That makes sense. Uh... I don't know how that help. Like, is that related to this? Well, okay, wait. The nilpotence degree. I guess there's no reason why changing your basis would preserve similarity, right? I think. I don't know. That's nilpotence degree of each eigenvalue. Oh, so that's the justification for why we might know the nilpotence degree. Is it? Like we could, instead of L, we could consider J? I don't know if that actually solves the problem. So, like, how do you characterize a conjugacy class? Like, if it's just by the character polynomial, I guess we have that, but is that good enough? If it's an if and only if, I guess it's good enough. Am I good enough? I don't know. Hmm. It seems like an if and only if kind of thing. So I guess we do know the conjugacy class. We submit the questions individually. I kind of want to hit submit on this. I did answer that. You can do it question by question? Okay. Check solution. Spoiler alert. Really? Okay. I I'm not torn up about getting the last two wrong. I'm glad I got the first four right. Surprisingly, little of the linear map is in general is determined by the character's polynomial of a map. The key reason that the character polynomial can't tell the difference between nilpotence and 0. We take the matrix 0, 1, 0, 0. This will have the same character polynomial x squared as the 0 matrix. Though they have a different rank, dimension of 0 eigenspace and nilpotence agree they are not similar. Hmm. The degree of the polynomial gives you identity, the factorization gives you distinct eigenvalues. Knowing the last one does imply all the others, though. Fair enough. Okay. Let's look at number 2. Although many properties aren't determined in general by character polynomial of a linear map, L end C of V? End. What is end? Is there like an endomorphism or something? Which of the following properties are determined by the characteristic polynomial on a general subset of NC? The space of maps V to V of linear maps? Okay. Entomology is study of ants. Entomology. Science would be ashamed, Fizzbuzz. See linear endomorphisms. So much faith in number 5. You did, Aeneas? It felt right. Is there a typo? I didn't see it. Which of the following properties are determined by the characteristic polynomial on a general subset of end C? That is, there's a codiment. What? Oh, Leo fixed a typo. Oh my, that really tripped me up. Okay. Yeah, you're on the ball, Leo. Yeah, Fluffy. This is a quiz from Leo Lectures. Just a question quiz. Which of the following properties are determined by the characteristic polynomial in a general subset of NC of V? That is, there's a codimension one subset subvariety of linear maps. What? Oh, that's true. Oh, guys, I wonder what the answer to this question here is. Oh no, I hope I get it right. Oh, look at me go. I'm so smart. No choice ends with a period? True. Or even an exclamation point. Or a question mark. Why would they? Boom. Boom, roasted. That is, there are codimension one subset subvariety of linear maps we can take out such that the following properties are uniquely determined away from that subset. I need to read this again because I don't know what it means. What? What did he change this time? That's definitely the answer. Many properties are determined in general by the characteristic polynomial of a linear map L and end C of V. Okay, so if there's some group of polynomials or some group of matrices, I guess, we could remove, what could we figure out from the characteristic polynomial? That's what this is saying. Surely if you take out matrices that are not of full rank, we can say a lot more. Should we say diagonalizable matrices to go even farther? I think we might need to. I probably boil it down to diagonalizable, and then we can know dimension, rank. The last two I still don't know. If W subspace of V, codimension of W is dim V over W. Volkswagen? Or, okay, dim V minus dim W. Did not know that. It seems almost too good to be true. Lane check is so you don't take out too many. The complement of the subset you take out has to be dense. Oh. Are non-diagonalizable matrices dense? Probably not. Maybe? I don't know. I don't know how you define... I don't know how you... I don't know what dense means in this context, to be honest. Uh... Every matrix with an epsilon of a matrix in your dense set. Mm. Are diagonalizable matrices dense? I'm dense. Does that help? I don't know how to. I have no clue if they're dense or not. I would think probably no if you're cautioning me. I only know like the intuition of what dense is. I don't know how you actually prove stuff with it. Do they feel dense? In vibe? No? I feel like they're equivalent of rational numbers, which are not dense, right? Or are they dense? I feel like I was corrected on that. I don't know. Um, hey, Borel. Dimension, rank. Dimension of each eigenspace. Is GL of V dense and end of V? General linear group, that's the group of all matrices with frickin' determinant not zero. I'm guessing no. I don't know though. Uh I I I almost want to say it's the same answer as before. That's where my gut is bringing me now. Like we still can't say that much. My pride it definitely is. What? Oh, you reset me. I already saw the answer. Well, hey, if you're gonna give me the opportunity. Ah, you pulled a switcheroo. Gotta believe in yourself. To remove all nilpotents, even repeated eigenvalues, passing to the subset of linear maps where the discriminative characteristic polynomial is non-zero. That's the condition that says that all eigenvalues are non-equal. I mean, wait, does this have meaning for higher degree polynomials, though? Can you talk about the discriminant for, like, a degree 5 polynomial? I don't know. How do you define it? There. Okay. I didn't know that. Uh, Product of squares of differences of the roots. Oh, okay. When the linear maps are determined on the dense subset of n to c of v, does not mean nilpotence nor repeated eigenvalues never come up for the linear maps in your life. You can get arbitrarily close to that not being the case. I think GL of v is dense because determinant of m equals 0 is an n-degree polynomial. I don't know in what sense. Have a game of respect for codimension 1. I don't know what codimension 1 really even means. I guess Floppy put the definition of codimension earlier. But I don't know what that... I don't know what that tells you in this question, still. GLV is the complement of all matrices with determinant 0. Sure. The space is n squared dimensional. Codim 1 means subspace of dimension n squared minus 1. Okay. The complement of a level set of a polynomial is always open and dense. I guess I'm imagining like a like if you have a polynomial that's like this, and you take a level set where it's equal to 3, let's say. Uh, is it literally true for a situation like this? I don't know. Check the quiz. I don't know. Do you know what's dense in GL? That's an applied math question. I don't know what's dense in GL. Refresh? Okay. Oh, did you refresh me? You refreshed me. Select every answer that applies. Yes and no. That's what I think. Yesn't. Well, I'm gonna guess no. I don't know how to even start with a question like this, so I'm just guessing. Yes, no, Dawn. So I guess the answer is no. See constant polynomials. I guess, are those the only issue? You got. Do I have to refresh again? Ugh. Yes, they are the only issue. Why not? Yeah, okay. There we go. You know, that would be great. Rookster, you're back? Okay. We can take a look at your integral. You wrote a little more? Hell yeah. All right. Instead of discussing linear algebra, we can do discussing calculus. All right. Uh, ignore that plus sign. It's not supposed to be there. I can you finesse me a spot? I should get a command to do this over on Twitch, but damn it, why doesn't YouTube make it easy for me to open up Leo's channel? Integration B semifinals? Yeah, so if it's integration B, I probably can't do it, but we can at least try. Leo Lectures does stream over on the YouTube side of things. So if you want more math streams, there's another source for you. Not in grad school, I cannot finesse you a spot. Sorry, Flofi. I see you in Stooky, Penn Center, and Zach. Yeah. I mean, Leo is saying that. I don't know if he'll do it. Or it's not Switch, or it's like dual stream. Getting beachfront property? If you don't get in this round, you're gonna have to quit math. No, you don't have to quit math. It took me basically 3 tries. I mean, or well, I guess like 2, but... No, yeah, that's a rule. But here's the ceiling of x over pi. It's tricky to think about here. Catch me doing math, I go to jail. How to quit math is terrible? Sounds terrible. Posted the solution in Discord? Okay, good. We'll try it for a while. I almost certainly cannot solve this though, so I'm pretty happy to just look at the solution. I gotta just go out there and fart a lot. Fart. It's good life advice. Okay. Oh, wait. Okay. Well, I don't know. Maybe don't wait. Maybe the first step is splitting it up like this. This sum is actually really finite. Euler summation formula and do a double integral. Maybe Fluffy? I'm gonna think about... I haven't heard of that, though. Okay, so on this first interval, the ceiling of x over pi is always 1. That's the point of doing this. And so that means it's just from... We just have an... From 0 to pi, I sine of x dx plus pi to 2 pi, our ceiling is always 2. So we get I sine x minus sine squared x. If it's not finite, it wouldn't be an integration context. Yeah. Yeah, if it was infinite, you probably have to like look for some way to switch the summation and integral or something. Okay. Hey, Parker. Is the ceiling of x over pi 1 on 0 to pi? Yeah? Yeah, okay. I felt floor at first for a second too. This is apparently an MIT integration B integral. I'm a little bit scared because I think I've solved it, but there's no way that I've actually solved an integration B question. Oh, it's not MIT? Oh, maybe it's possible. Oh, German. That's right. You said a uni in Germany. Wait, shouldn't this be plus? It should. Okay, we just need to evaluate these and we have the answer. You think MIT problems are quite easy? No, they're not. At least not the MIT integration B. Those are very difficult. Maybe they have other questions that are high school level. I could solve MIT integration B problems, not with the knowledge I currently have, and I don't care to study. That's the problem. What GPU do I use? Not a good one. It's a 1660 Ti. I'm not gonna do these integrals by hand. I will Wolfram Alpha them though. They're just like tedious and not actually challenging. So I don't want to do them. Um, no, the problem with MIT integration B questions is you need, I don't know why I'm debating whether they're cursed or not. You need shit like King's Rule or Queen's Rule. And like, you need to know just all those like tricks. And I hate tricks. I hate, I hate vague tricks like that. Tricks that work often, I like. If we could show that NV over or minus GLV doesn't have open subsets, we would know that GLV is dense because it's open. I have no clue. I think we could cook some idea with adding small diagonal matrix makes a non-invertible matrix invertible. I couldn't tell you, Aeneas. Isn't applied math and analysis full of tricks? I don't get it. Well, some tricks are better than other tricks. Is on 3000 ping? No, I... Or maybe you just asked an interesting question, Leo, and Aeneas is still thinking about it. Will you assume I've said anything interesting? Hey, ND Vines, it has been a minute. Has viewers from the Snowy Mountains with 3K ping. You have to go pretend to play say the spiral. I'm really thinking about how cool it'd be to be one of those goats hanging out on a flat rock face. My god. Very important. Enjoy, Leo. Thank you for the problems and for hanging out. Okay, we just need to evaluate these and we're done. Cosine of 4 pi is positive 1. So we get minus I. Cosine of 0 is 1. So we get minus I. Really? Oh, right. You integrate cosine over a period, you get 0. Good. Okay. What do I get from you? 4 pi. This is 0. Minus pi. Still 0? Yeah. 1/12i. What do we get here? Cosine of 12 pi is 1. Cosine of 4 pi is 1, so 9. 6 pi is 1. Minus 9. Oh, wait, this is still cosine integrated over a period. This will 0 out. Um, 48 pi 0 0 36 pi 0 0. Okay, then we have to evaluate this. What's the trick in math that I'm most proud of knowing? Ooh. My mind immediately goes to PDEs. And a trick that's frequently really helpful in PDEs is... knowing that the integral of something squared is greater than or equal to 0. This is crazy helpful, actually. So that's like a trick that comes up in a lot of like proofs. I guess I don't. You said proud though. I think maybe a cooler trick that I might be more proud of knowing is let's say this is your domain omega, and on the upper part of the boundary you have boundary value 1, on the lower part you have boundary value 0. You could solve, like, just by looking at this, you can figure out how a harmonic function would behave on this domain. Like, you can just solve this just using your gut, basically. It's like, if you want to know, like, the level set where u equals 0.5, it's not exactly halfway between 0 and 1, but it's somewhere around halfway between 0 and 1. So it's something like that. It's the level set of all x such that u of x is equal to 0.5. So that's like a fun trick. If you had absolute value, you get L2 norm. Yeah, exactly. Been 7 months I just completed high school, so I'm able to get into a good university. And Divines, I'm sorry to hear that. But life isn't over, and I'm sure you'll find a way to move forward. Good luck with whatever you do move on to. Okay. Yeah, like differential equations has a lot of tricks. Do you think university makes a student or vice versa? I think it depends on the student. Because people like Ramanujan will always exist who never had any formal schooling. Or at least any advanced form of schooling. I don't remember his entire life story. But most people do. Like they are kind of formed by school. So I would say it's not necessary, but frequently yes. The university makes the student. I would say the thing that's probably always true is mentors make students. I think even Ranazan had mentors. I don't know. That zeroes out. This is 3 pi, so minus 3 pi over 2. This zeroes out. 12 pi over 32. 3 pi over 8 if we divide it by 4. Yeah. It's a negative number? That's so ugly. Ew. Minus 9 pi over 8? Did it, Ludwig? What did you do? That's the answer? They could have engineered a prettier answer than that. I'm surprised that one was... Like, normally these competition integrals are a lot harder. I'm glad that one's actually doable. Yeah, I have seen that trick before with integrals of when you have the floor or the ceiling, you just divide it up into different intervals. And then you can resolve the floor or ceiling before you actually integrate. So the guy did exactly? Oh, cool, cool. Don Pride recovered. Don linear algebra education needed. Okay. Feel free to ask me more questions. Otherwise, I guess we'll get back into puzzles. Thank you for the question, by the way, Roxra. Don Pride positive definite. Gonna make me do your physics homework? I mean, it'll be pretty obvious if you're trying to make me actually do your homework, but I'm definitely willing to help out as much as I can. Okay, so we did 3 squares. I think we need to do how many items now? You're gonna be doing mechanics, right? Oh yeah, AP Physics 1. Ugh. I should be able to handle it, at least up to a certain point. An item is made from lead blanks in a lathe shop. Mechanics is next year. Oh wait, you're not doing physics now though, right? Each blank suffices for 1 item. Yeah, next school year. Oh yeah, so as in like in a few months. Or in a month, maybe. Okay. Each blank suffices for, wait, what is I don't know what a lead blank is. Like a bullet casing? Sure, Dessen. Each blank suffices for 1 item. Lead shavings accumulated from making 6 items can be melted and made into a blank. I'm stuck on what a blank is. Oh, oh my god. Show the automorphism of z mod 30 is equal to the automorphism of z mod 15. Is that for addition? I can't remember. Or is it multiplication? Like z mod 30? It's very hard to move on from a university, even more harder than moving on in a relationship. I prepared for the exam, I still couldn't get in. Yeah, and Divines. I'm sorry. Okay. I guess we just did a question from you, Roxra. I'm gonna think about Destin's first, and then I'll work on yours after. 42. Once again, I'm pulling up this. What is an automorphism is my first question. Okay, we need to know what an isomorphism is first. An isomorphism phi from a group G to a group G bar is a one-to-one mapping or function from G onto G bar that preserves the group operation. That is, phi of AB is equal to phi of A, phi of B for all A, B, and G. There's an isomorphism from G onto G bar. We say that G and G bar are isomorphic and write that. Definition of isomorphism ensures that if phi is an isomorphism from G to G bar, table can be obtained for operation table G. Same order. Galleon was a yapper. And this is the book that I was self-studying for when Penn Center was doing the abstract algebra reading group. I only got as far I think it's chapter 5, though. And chapter 5 was a real slog. Find a candidate for isomorphism. 1-to-1. Prove that phi is 1-to-1. Assume phi of A equals phi of B. Prove A equals B. On 2. For an element G bar and G bar, find an element G and G such that phi of G equals G bar. Prove that phi is operation preserving. Okay. So isomorphism from G onto itself. That I don't know what that's supposed to look like. I guess that's why we have examples. The function phi from C to C is given by phi A plus bi is equal to A minus bi as an automorphism. Prove complex numbers under addition. So is the question that every automorphism on integers mod 30 is also an automorphism on integers mod 15? That's what the question says. Okay. Um, you're saying an example of why algebra is easier. So should be anything overly complicated. Hmm. Oh, is it? Is that actually what does that exponent of x mean? Zero is gone? I don't know what that means for us. Z10 is so simple, it's not difficult to do. You know alpha of 1, we know alpha of k for any k. What? Okay. Okay, wait, I think I understand that then. Maybe? Determine the choices for alpha 1 that make alpha an automorphism of Z10. Okay, I don't understand if alpha is an element of the automorphism. Oh, alpha's a function. Okay. This is an element of the automorphism, not an element of Z10. Oh! It's like, okay, that X is supposed to be a star. Okay, okay, okay. Forty-five theorem 6.2 tells alpha of 1 is 10. The order of alpha of 1 is 10. There are 4 candidates for alpha of 1. 379. Three x mod 10 equals 3y mod 10. Oh god. I'm sorry, I still don't know how to even start on this question. C asterisk? Chinese remainder theorem? Oh. Ugh. It's been too long since I've used that. If one knows the remainder is Euclidean division of an integer n by several integers, one can determine uniquely the remainder of the division of n by the product of those integers. I do not know what that means. Pairwise coprime. If a1 to ak are integers such that... Okay. There's only one integer x. It becomes a ring. I don't know that. Is it supposed to show that algebra is easier? Like, I don't know any of this, Destin. I'm sorry. As soon as rings get involved, I already don't like. I already don't know what I'm doing with automorphisms. I know even less what I'm doing with rings. Uh, yeah, that doesn't like I'm about to give up here. I don't know what the fuck I'm doing. If you want, you could just give me the answer and I'll try to understand it. But like, I can't solve this on my own. I mean, I assume it's something to do with this. Like, UN is integer multiplication, I think mod n. And 15 and 30 are, like, 15 is a factor of 30, which I assume is going to be important. But I just physically don't know the language to use to actually say what you want me to say, Desson. And I do have Brooks's question waiting, so if I don't hear anything, I'm just going to go and do Brooks's question. God damn it, Desson. Well, they just aren't equal to each other, though. I I still don't know what the question is. Like, the cardinality? No, like, the cardinality wouldn't be equal either. Do you mean isomorphic? Instead of, like, equals? Like, the double tilde? Hey, non-dairy neutrino. It's been a minute. Hope you've been good. Oh, wow. Thank you so much for the prime, dude. I appreciate it. The cream will rise to the top. Kinetic football dev suffering? Me too. Anytime that there's algebra on the screen, there's suffering. Yeah, I'm sorry, Destin. I have no clue. And I do want to do Rogue's question. Yeah, I have a bunch of possible alerts, and it just chooses a random one. I do enjoy that alert, though. Destin is trying to show me something in abstract algebra, and I'm crashing and burning because I'm terrible at abstract algebra. And so I'm about to run away from this question like a coward. And look at Rogue's physics homework instead. It's like a monoid. I do know that's an algebra term. I couldn't tell you. I mean, a monoid is just like you don't have inverse or something, maybe. It's actually my homework. Yeah. Kev's worse. You enjoy solving bond cells, calculus, and definite integral. Those geometry applications are killing me. Oh, yeah, there can be some tricky applications. For sure. Okay, you record the position of your car at even time intervals. Use the data to find the exact mathematical relation between position and time. If it helps you, Rookster, if you actually need help with this, I will do it. I don't care if it's like too simple for me. The y-intercept should be visible in the graph. The bottom part? Okay. Label your axes and include units. There are two grids. Use one to graph the directly measured data, the other to linearize the graph. From the graph, determine a mathematical formulation of the position at any time. Lastly, give an explanation of your formula in words. Make sure to give an explanation of the slope and y-intercept of your formula. Proportionality equation. Huh. A second difference of quadratic. I think that will be if it's like falling under gravity. This would be like a first difference. Is what I'm thinking. Okay, I think I do need to, in order to do the bottom part, I do need to see what the top part is. Oh, that's what you mean. Are they consistent? I can, let's graph it and see. This is time. I guess they're saying y-intercept, so we'll say this is y for position. Physics, a real science, unlike math. Yep. Hard agree. Oh, we have to figure out scaling. Oh my god. 1, 2, 3, 4, 5, 6. Oh, this is a terrible question. You want me to do linear regression? This is a... Oh my... Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you want me to go up to 130. I can't even break it up into clean intervals. Oh my god. Okay, like, going by 13 would be stupid. I'm gonna go by 13, I guess. I'm just noticing 129 is just under 130, and 110 goes into 130. That's why I'm doing this. So 13, 26, 39, all the way up to 130 up here. I think it's a terrible... I hate this question. Okay. First thing to graph is 1, 9. Guesstimating it to be right there. 2, 24. Guesstimating it to be right there. 3, 49. don't know, right there. 4,84? Ugh. $13 is like the worst number. 91. What kind of godforsaken number goes into 91? $84. There-ish. This doesn't even look linear. What did 91 do? I don't know. Not much, to be honest. Okay. Finding area was good as soon as polar complex forms enter the picture. Just fly away into rabbit holes using integrals. Yeah, kinetic football. That's understandable. Okay, so if we use the same scaling, I think what they want us to do is just draw a line that looks good, I guess? There's a way that you can actually calculate the best line. They're not saying to do that, though. Right. But, like, they want us to do this by hand, right? Like, I guess a line that looks something like that is what I would draw. Wait, why is that different? Oh, because because the picture isn't perfectly square. And that's fine. It's kind of trippy that it didn't work to do it like that. Okay. Yeah, perspective is weird. Homework made me remember I had bad grades in school. This problem sucks. P versus T squared. What do you mean? Like, you want to square all the times? That might have some interesting... That might look interesting on a graph. I don't... Is there a simple way that we can do that that doesn't involve me doing even more drawing than I already have? New millennial price... millennial prize problem? Millennium prize problem. A millennial prize problem would be like buying a house or something. To linearize? I mean, I'm not quite sure what the homework assignment means by linearize. I don't know what you can do besides just eyeballing a line that goes through the graph. It does kind of look parabola-ish. No. Was that leaked, Desson? Here's T-squared makes a linear graph. Really? What are these differences? 15. 25. 35? Really? So, Lagrange interpolation, true. All of math is just saying numbers, Leo. Well, that's all of physics. Put in Slum's Discord? Okay. Well, I definitely don't want to do algebra. I'd rather do a calc question than this, but Rocher's asking for help with it, so... We're gonna do it. What does that mean if you square the time you get a parabola? Like, that's weird. Hey, you and algebra. Algebra sucks. There, I said it. Like 149. I don't think it's a line if it's t squared. Is it? It can't be a line. Well, no, the issue is that these differences... Oh, wait, no, it might be a line. I might just be dumb. I really don't want to test this. Is it actually helpful to know that that's a line? How do you start a derivation? The question, you have to derive an equation for r as a function of theta for a uniform parabola. Focus polar coordinate direction says passing through the origin of the angle phi. That sounds really complicated. All you can do is think about what you do know and try to just like write out facts that you have that may or may not be helpful. So like, I don't know. I don't have a very good answer for you for that one, kinetic football dev, but like you're probably being asked the question because you have the tools to solve it. So think about the tools that you have. The more we talk about this homework assignment, the more I hate it. Y is equal to 5t squared plus 4? Does that check out? If you plug in t equals 1, you get 9. If you plug in t equals 2, you get 24. If you plug in t equals 3, you get 49. That looks pretty good so far. T equals 484. Why didn't they use gravity if they wanted to do this? I guess because of the coefficient? Like they want a 5 instead of a g? Or 1/2 g? Gravity's not even real. Your summer homework sucks, Roxro. I don't know what this is teaching you. Okay, so... Are they trying to say it's linear in t squared? Or, like... I don't know what they want with... a linearized graph. You bet t squared could be linear? Like, you could make that scale t squared and this scale y? And you would have 1, 4, 9, 16, 25, and your graph would be a... Well, it's not going to look... I mean, I guess it would be a perfect... You would have a straight line. It's weird because the scales are squished. Okay. So my tools, conjugate coordinate system. Yeah, kinetic football dev. I'm really not sure. Hey, Lucas. But Destin, I will come back around to your calculus question. Take an angle theta from the z-axis to try your best. Yeah, good luck. Is it true if a polynomial p is such that the difference is p of n plus 1 minus p of n of polynomial degree d? Uh... I gotta think about that, Aeneas, I'm not sure. Let me keep on with this question first. You're back? Okay. So, yeah, definitely would not over rely on AI, kinetic. Rockstar, I guess you figured it out, that, like, I think this is basically what they would want for the linearizing part. Calling that linearizing is stupid, I think, but I think that's what they want. Um, what's the proportionality? I think they want y is proportional to t squared. I think that's how we normally write proportional, like with the tilde. And the equation is what you wrote. Here's the answer, and only difference z mod 2 to the x, or star, whatever. It's just 1. So are you talking about the cardinality, Destin? That's what I didn't understand. Like, you say the integers mod 2 star is just 1. I don't know what that means. Or like the order. So this car is accelerating. The goal is to approximately model the motion as if the car is moving at a constant velocity. Let's get a straight line of position versus time. That's what I thought at first, but I don't think we're even doing that. Like, I thought we were doing a linear regression, but I don't think we are. I don't know. Explanation of the formula in words. Yeah, Leo definitely hangs out on JC's channel too. Syntax, I'll read that in a minute. Oh, well, that's not easy to read. Position. The square of time that car is accelerating. So I agree that it's accelerating, but like, I don't know. I stand by my opinion that this question sucks, and it should feel bad about itself. That's what I thought too, non-dairy neutrino. It might be that, but like, I honestly, I don't know. Because saying something is linear in t squared is super weird, and like, I guess you can do it, but I wouldn't want to do it. Um, so yeah, Rookster, I'm sorry. It could be what non-dairy neutrino was saying. It could be what you said originally here too, or like what I have put here. I'm just not sure. Um. Okay. Good luck, Rookster. Okay, so we had like 3 questions pop up in chat while we were talking about that. Um, from Aeneas. From Syntax. I guess so doesn't. I don't know. It also be allowed to say y is proportional to just t, so I'm very confused by what they're going for, like what the intention of that question is. Okay, and then this last question is from Dessen. Will be linear in t squared. Position velocity is 0. And t squared is idk. X equals an over 2. That's kind of why I was thinking they wanted something like that, but it could be just a dirty by hand linear regression too. I honestly I'm confused by which one they want. I think both of those are reasonable enough interpretations of the question. And I just think it's a crappy question. How many LinkedIn connections before I get hired? I'll let you know when I get a job. Good question for a lab assignment? I think it needs different wording. Show that f of z equals 0. I'm looking at the last question right now. F is an entire function. Oh, I mean, for Dessen's, isn't this just... We're integrating over the entire complex plane. And we know it's entire. Yeah, like, I guess, like, there's a good question hidden somewhere in there. It's just... They need to actually say what the question is. um... What's the name of that thing in complex analysis? The integral of an analytic function is always 0. I think that's all we need. Integral of analytic function, complex analysis. Is it just Cauchy's integral formula? It is. That's what I was gonna say, but I thought it was something different. Or, well, no. Dang it, it's gonna bother me. 1 second. Um, Is it just Cauchy's theorem? Oh, just Cauchy's theorem, I guess. Okay. Yeah, it's basically that. And I guess it's an area. Okay, I guess that's where a line or like a contour integral, and this is maybe it's actually not that. I feel like there's gotta be connection though. Sounds good, kinetic. Good luck. Sleep well. Is it like a Green's theorem? Entire bounded equals constant. So there exists some f prime. Yeah, it is. So, yeah. It's not as like it's not like one step like I was thinking though. It's like maybe two or three, but I think the idea is that it just is going to come down to Cauchy's theorem. Meant to be a play on words. Is it? Oh God, I guess I'm slow. Show f of z is 0. Oh wait, no, aren't I? Oh my God, I had put an integral. Yeah, never mind. I'm in the complete wrong headspace for this. This is more like Liouville or something. F is entire, which means f is harmonic. And a bounded harmonic function has to be constant. Why does it have to be 0? Oh, because then the integral wouldn't be finite. Okay. There we go. I think that must be the answer. There we go. That's the answer. I don't know how to spell Liouville, by the way. Okay, one question down. Um, I guess let's. Anius posted this top question before syntax, so let's look at Anius's first. If a polynomial p is such that the differences pn plus 1 minus pn is a polynomial degree d evaluated at n, p is degree d plus 1. That feels like it's probably true. How do we do this in general? Oh, for the last one? Liouville's theorem says that for analytic functions... sorry, if a function is harmonic and bounded, it is constant. That's what Liouville's theorem says. Uh, it has to be bounded, or else the L2 norm wouldn't be finite. You have to use orthogonal relations to deal with the integral. Do you? Oh, well, wait. Are you saying you could have an unbounded function on the entire complex plane with a finite norm? How would that be possible? I mean, we know it's entire. It has to be differentiable. No, it's not going to talk about orthogonal relations. Well, that's annoying. I think it's 1 over x. I mean, we know it's entire, though. So, like, something like 1 over x shouldn't be allowable. Just an integral of f squared in polar form. Consider you grow it to 1 over epsilon on chunks of measure epsilon squared over 2 to the n. I don't know what that means. Post it on Discord? Okay. I feel strongly that if a function is entire and has a bounded L2 norm, then it should also be bounded. I don't know if that, I guess that doesn't, maybe that it's possible to not be true, but then, oh, the music just stopped. 1 second. Okay, so you want to use a power series because it's entire? What are you going to do with this power series? So, okay. Shove this downwards. Um, the integral over the complex plane f of z squared dx dy is equal to the integral from minus pi to pi 0 0 to infinity. Like that. And then, I mean, the R kind of seems like a problem. But wait, do we Cauchy-Schwarz? I have a feeling we Cauchy-Schwarz. Get the radius in the denominator, take the limit R to infinity. Always Cauchy-Schwarz. I remember how it works here. So like we want to get, I guess syntax, thank you for posting about that one. I'll look at that in a minute. It might be more than a minute, I'm sorry. Do we need to do something stupid like this first though? Because I want to Cauchy-Schwarz on just this inner integral. Yeah, I don't know. You posted a problem too that I want to get to. Yeah, they are. I forget how Cauchy-Schwarz goes for an integral that looks like this. And every time I look at the Wikipedia page for Cauchy-Schwarz, they give the very general definition with inner products, and I don't remember how that works here. So I'm looking for an example in my PDE notes for where we use Cauchy-Schwarz. Oh wait, I think I remember. Do I remember? Oh wait, this is gonna be weird. Cauchy on my Schwarz to light inequality. True. I can't easily find a Cauchy-Schwarz example. I'm nervous I'm gonna mess it up. You know what? Oh no, never mind. I thought I could think of a place where I used it, but I think I used it wrong. Okay. Here's a Cauchy-Schwarz for my notes. Wait, oh, this is stupid if I do it like that. Never mind. I don't think this helps. I don't know how to use it in a helpful way. I thought I could use Cauchy-Schwarz to get the squared on the outside of the integral. That's not actually how it works, though. Why am I trying to get that on the outside? Oh, right. I'm trying to make the integral in R this F here. My favorite inequality besides triangle and Cauchy-Schwarz. Problem posed in passing by inspired by the y proportional to t squared homework. Not that I'm not curious to see it solved. Okay. Favorite inequality besides triangle inequality and Cauchy-Schwarz. Those are like the two big ones. Oh, that's another thing I learned from my PD's class. Let me find the name of it. The isoparametric inequality. In two dimensions, the isoparametric inequality is the boundary of some domain omega, the length of the boundary, is greater than or equal to 2 root pi times the area of the boundary square rooted. And you get perfect equality, like when omega is a circle. And so in some sense, it says that circles are the optimal area for fixed perimeter, I want to say. Or maybe vice versa also. Maybe it says both ways, I don't know. So yeah, isoparametric inequality is pretty cool. Isn't f of z squared equal to f of z times conjugate f of z? Ooh. Chebyshev and Young? I know of Young's, I don't know of Chebyshev. Truthful inequality as an algebraist? I wouldn't know if that's even related to algebra, to be honest. Who's short rated to Banach algebras? Oh, it probably is. It might be a requirement to be, or I don't know. I don't remember anymore. Yeah, I'm. I have too many questions waiting for me to want to spend more time on this problem. I'm sorry. I don't know how to progress on it. If I can, because I feel bad that Aeneas and Syntax have both asked questions and I'm just ignoring them. So I don't know what more to do with this question, Destin. I'm sorry. So I can't like quickly figure it out. Um, Let me read what Destin, sorry, what Syntax said about Aeneas's problem. I can't scroll up in my Twitch chat because Twitch is stupid. Let me just slash user syntax. This is what syntax said earlier about this problem. It's always true if degree of p is k. Codimension 1 close to the answer? Okay. Degree of p is k. P of x plus 1 minus p of x is k minus 1. Why is that if degree of p of x plus 1 minus p of x? And isn't this the exact... This sentence is the exact, like, problem that Anis was asking, isn't it? This is j, then p of x degree is j minus 1. F is entire. It is constant, or f of z goes to infinity. Yeah, Anis, that's Liouville's theorem. Oh, if you're okay. It's about the order of the if then. Degree. Okay, I'm sorry, I'm not doing it. I'm getting really tired. I'm gonna have the stream after I think about Anis and syntaxes, but even then, I can feel myself getting stupid as I think more. Um, yeah, honestly, I don't know what else to say about Anis's right now. Let me just read what syntax has to say. I mean, I've done math for like 6 hours before. Just depends on the day, I guess. And today I'm feeling tired because people keep asking me like algebra questions just to torture me. I can come back to Anis's question. I'm just not sure what to do with it right now. If x has rational coefficients, has root alpha not in Q. Oh, okay, sure. You can have rational coefficients that result in irrational roots. Is there any sort of idea of polynomial also in Q of x are close, but all of Q's roots are rational? Huh. I feel like there's something there, syntax. Because we can definitely make rational we can find a sequence of rational numbers that approaches any irrational number, right? Or at least any algebraic one, or not counting weird irrationals that I don't know about. Um, I think it's any irrational. Well, okay, so Euclidean algorithm. we do think very differently, Dustin. So if P has in like let's just say that R1 is irrational. Can't we say that like can we form a sequence? Sounds good, Rookstra. Good luck. See you later. Can't we just single out the irrational root and create some sequence like B sub n such that B sub n approaches R1 as n goes to infinity? So then Q would be... No. Well, I guess... Okay, maybe let's not double up on ends. BM, haha. Oh, I wasn't even doing that on purpose. But I'm sticking with it now. Yeah, that's basically what I'm trying to say here. I mean, not that that is trivial, but that you can use limits of rationals. Okay, well, at least that's one thing that I could do. Oh, I mean, in English, it's short for poop, basically. Is it something like terrible in Spanish? Oh, okay. I won't ask then. Well, I should have started with syntaxes question then. I feel kind of bad about that, but oh well. Yeah. Uh, I wonder if there's like a Vietas type of thing, because I know that Vietas formulas relate the roots to the coefficients, right? I don't know if it's specific enough though, because it's like you can't isolate the irrational root though. You asked me the better looking questions? I guess so. I did do yours first. I mean, I did yours first because I misread it and I thought I solved it immediately, but I didn't. Or like, it could be an interesting thing if you don't know what the irrational root is. But then you're just getting to numerical approximations. Never mind. I don't know any density facts. I don't even know the formal definition of density. I only know intuitively what it means. Obi, thank you so much for the raid. I hope your stream was good. What were you talking about? We've been working on a few different problems. Let me get this so it's further off the screen. I was probably just wrapping things up soon, but I wanted to see if I could figure out anything to say about Andy's question that's at the top here. This other comment is something that syntax error put interchapter to PDEs. Ooh, that's exciting. Yeah, for anyone here on my end, please do check out Nsimplex Pachinko, aka Obi. Fellow math streamer, awesome dude. And apparently starting to stream out PDEs. A good fact to know, for instance, is that continuous functions with compact support are dense in LP spaces above 1. Huh. Actually, And I assume you're not just counting... Well... Okay. I have no idea how you go about proving that, or what it actually means, I guess, but... It's weird that there's a cutoff for P being above 1. Density. You get some stuff that's in between some other stuff, such that no matter where you look around and stuff, you always see other stuff. That's basically how I think of it, like... Actually, I don't even know. I always thought that the rationals were not dense in R, but apparently they are. Isn't there an issue? Let's say P of x equals x squared minus 2. It doesn't factor into x minus r times q of x, where q is in q of x. Oh, are you saying for this one, Aeneas? I didn't think about irreducible quadratics. Or... Oh yeah, or even, yeah. I don't think we're... are we? Hyperbolic matrices are dense and... I don't know what a hyperbolic matrix is. Take something in the complement, perturb it a little, like epsilon must fall in the dense subset. Okay. Ugh. Hmm. Yeah, I assume it needs to come about this problem. Solve me? It actually does look kind of interesting, but I'm not going to. At least not right now. Yeah, that's true, Aeneas. Or... Wait, so well, irrational roots, they have to come in conjugates, right? Well, actually no, is that true? What about what about a degree 3? Or like, what about odd degrees? They probably still have to come in conjugates. Because if you have rational coefficients, um, the radicals have to cancel, right? Compute the Coet's orbit. I'll pass. It's a refund. How does x cubed? I feel like I should just know that. I know 1 is a root of that. No, it's not. Oh my god, did I just say that 1 is a root of that? That's why I need to freaking call the stream soon. Oh. Huh. What an annoying function. Wow. Rational coefficients, not a single rational root. Yeah, that's true. Yeah, as long as we can factor it, this rational approximation still works, right? I don't know. My brain is kind of imploding. Acerbic piglet. Uh, I don't know how to answer that question. It's a math stream. You can ask questions. This is a question that someone asked. Friends with Galois theory? Maybe. I don't know. I kind of feel like I should just call it. Annie said, I'm not sure what to say about the problem that you posted. I'm sorry. And syntax, I don't know what else to say about this, and I kind of just want to go and take a break. So, yeah, I think I'll do that. So yeah, people here on YouTube, thank you for being here. Just will look for a raid. So goodbye, YouTube.